Okay, so now let's start the introduction. This class name is Mechanics and Material Science, or as we said, Mechanics of Materials. Why do we need this class? Well, we said the prerequisite for this class is statics. But statics itself is not enough for mechanical engineer or for many other engineering disciplines. We have to go from statics to actual mechanics of material, and the reason behind it is in statics when we deal with this material or component, quite often we say the material we are dealing with are so-called rigid body. What does it mean? It means the material will not deform or break under the load that you apply. But that is a highly idealized situation. In reality, we are going to deal with practical engineering material that has certain so-called elasticity or and plasticity. They would change shape upon application of load, and when the load is too high, they may break or fracture in various ways. Because of this reality, we have to evolve. Our knowledge has to gradually evolve from dealing with only rigid body to practical engineering material. And we have to go from pure statics, highly idealized situation, to actual mechanics of materials. And as we said before, for when we deal with rigid body in statics, we don't even consider any failure. But in reality, as the load increase, at a certain point, no matter how strong the material is, how hard it is, we will see failures in the form of fracture, of fatigue, or creep. And that's what we are going to cover in this class. And this class, statics of mechanics of material, will serve as an important foundation for many other advanced courses in mechanical engineering as well as in other related disciplines. For example, for your future mechanical design, for your future finite element analysis, for the future synthesis of engineering mechanics, all these more advanced classes in junior or senior level would be based on this class. That's why we have to teach mechanics material after statics. Okay, before we go into the content, let's look at some examples of so-called material failures, specifically mechanical failures. Here I have here a photo of a collapsed bridge actually near FIU. From mechanics point of view, it's a failure of the concrete and related cement and steel material that engineers use to construct this bridge. That's actual example of failure of material under certain load. Another example I showed here, part of an airplane engine that failed earlier in 2018. The broken engine part shot through this airplane window and critically wounded the passenger. This is another example of a mechanical failure of actual practical material that consists of the engine part. And then some day-to-day examples. Here I showed photos of a actually cup. What types of cup? It's made of stainless steel, but you see if you look at it carefully at the rim of this cup, you find tiny cracks. that formed. This crack is a mechanical failure in the material that is used to construct this cup. Another example. And finally, believe it or not, this is a photo that I had taken when I used this knife to cut ice cream. And because the ice cream was frozen, it was pretty hard. And when I applied force to the ice cream, believe it or not, this steel knife actually broke or mechanically failed and broke into these two pieces. Another example. So from these examples, you see practical material will change shape, and in extreme case, they may crack and even completely break, like these situations. And as an engineer, we need to know what's a design limit from material point of view, from geometry point of view, when we consider different applications, so that we can design safe structure, safe application to avoid these catastrophic failures. So, what is mechanics of material? Well, it is a branch of mechanics that develop the relationships between, on one hand, external loads, the force that you apply to a component, to a system, and on the other hand, the internal force intensity, or we call stress, and the resulting deformation or change of shape or strain in the material, or even failure, which people sometimes also call fracture, breakage. That's what this course will be dealing with. The relationship between external load and internal force intensity, stress, and the deformation of shape change, which is strain and even failure. That's what this course is about. In Wikipedia, there's another definition. It says strength of materials, also called mechanics of material, is a subject which deals with the behavior of object subjected to stresses and strains. So for statics, in that class, we primarily dealt with equilibrium. What does equilibrium mean? It means, as we see, balance of force along x direction, along y direction, maybe sometimes along z direction, as well as balance of moment. Balance of moment. That these set of questions are what we got from statics. On the other hand, when we move to mechanics of material, then we are going to deal with something in addition to balance of force, balance of moment. For example, we'll deal with the so-called stress and strain for practical engineering component under load. We'll explain what stress and strain mean. Okay, we will also deal with some so-called statically indeterminate problems. Statically indeterminate means those problems based on only balance of force and balance of moment cannot be solved. But when we started to consider something else, started to consider the geometry, we can now solve them. Okay? And in this class, we'll also deal with the deformation or change of shape of engineering component under practical load. And in some cases, we may even have to deal with yielding, the so-called plastic deformation, and eventual failure, the breakage of engineering components. These things what we are going to deal with in this class, as opposed to rigid body, which are dealt with in statics.